All right, so Dr. McHenry Leblanc, thank you so much for joining us from Louisiana, our NASA Solar System Ambassador and my high school classmate that I have known for 25 years. Um, Appreciate you joining us today. I know you're extremely busy being a mom and doing all your science stuff. I've got a room full here at Velma Jackson High School, and we're recording this for our STEM students in Madison County Schools at Madison Middle School, Germantown High School, Old Town Middle School, and Shirley Simmons Middle School as well. So I know you wanted to get into this, and I'll let you narrate it and explain what's going on. And we got some great questions we're going to get to from the students as well. So we actually have a lot of questions about what you are, what all you do. So we'd love to hear all about it.
Awesome. All right, here we go. Oops, I'm so sorry. Hold on. There we go.
9, 8, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I don't know what's going on. Hold on. I'm so sorry. Here we go. There we go. Dr. Melanie McHenry.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
This is an introduction to NASA by me, Dr. Melanie McHenry LeBlanc. Why didn't Orion laugh at the joke? Because it was too serious. Who am I? A little bit about myself. I have 3 degrees, with the highest being a doctorate in environmental science from Jackson State University. I've been a NOAA researcher studying heavy metals. I've been an assistant professor of biology, a lead laboratory scientist studying tissue samples, and now I'm a solar system ambassador. I'm also the mom of Jack and Jacob. Hi, it's Dr. Melanie McHenry LeBlanc, and I just wanted to tell you guys why I love NASA. I love NASA because I love innovation and exploration. History time! The Dogon people of Mali were the first people in the world to know about Saturn's rings, the spiral structure of Jupiter's moons, the Milky Way, Saurus B, and the Saurus star system. The Skull Nebula. Everything has an origin story. This is how NASA began. The space race with Russia. NASA was created on October 1st, 1958 in response to the Russians' launch of Sputnik. NASA was organized around the National Advisory Committee for Aeronautics that started in 1915. History time. The oldest mathematics object in the world was found in Swaziland, Africa. The oldest example of arithmetic was found in Zaire. The 4,000-year-old Moscow papyrus containing geometry was from the Middle Kingdom of Egypt. What has NASA done?
It's one small step for man, one giant leap for mankind.
We have had over 50 years of spacewalking. From 1961 to 1966, we had Gemini. We gained orbital capabilities. From 1961 to 1972, we had Apollo, which was lunar surface exploration. From 1973 to 1979, we had Skylab, and we learned how to spacewalk and service maintenance operations. From 1972 to 2011, we had the space shuttles. We had 82 spacewalks. From 1990 to present, we've had Hubble. And we've had the PLSS, which is Advanced Life Support Development. And we're looking for a new support system, and we're also looking to explore Mars. The timeline of space exploration. In 1957, NASA had Sputnik. In 1958, NASA was established. In 1961, the first human in space is Yuri Gagarin, who's Russian. From 1966, we had the first probe on the moon, Luna 9, also Russian. 1969, we had the first humans on the moon. In 1975, we had the first probe on Venus, Venera 7, which was Russian. In 1977, we had Voyager 1 or 2 are launched. In 1981, first reusable space shuttle was used. In 1995, first probe on Jupiter. 1998, we had the International Space Shuttle. In 2015, we had the first reusable rocket, Falcon 9 by SpaceX. History time, NAPTA play is like Stonehenge but older. It is found in Kenya. It's man-made and over 7,000 years old. It's the oldest stone circle in the world. This is the oldest known astronomical site on Earth. A black hole. Current NASA projects and why they should matter to you. We are going back to the moon. By 2024, NASA will land the first woman and the next man on the moon. We'll explore more of the lunar surface than ever before. We'll collaborate with our commercial and international partners and establish sustainable exploration. Searching for life or elements of life on Jupiter's moon Europa and Saturn's moon Titan. On Saturn's moon Titan, we're going to use a drone-like hovercraft called Dragonfly. It's going to explore the prebiotic chemistry and ability of dozens of sites on Saturn's moon. It's going to advance our search for the building blocks of life. On Jupiter's moon Europa, we have a planned mission to investigate whether the icy moon could harbor conditions suitable for life. The next NASA project is building enhanced space vehicles. We have Exploration Ground Systems. Its primary objective is to process and launch the next generation vehicles and spacecraft designed to achieve NASA's goals for space exploration. Then we have the multi-purpose crew vehicle Orion Mpcv. The multi-purpose crew vehicle will serve as the primary crew vehicle for missions beyond low Earth orbit. It is capable of conducting regular in-space operations in conjunction with payloads delivered to the Space Launch System. Maintaining and advancing the International Space Station, also known as ISS. The ISS is an unprecedented achievement in global human endeavors to conceive, plan, build, operate, and utilize our research platform in space. It has a full-time crew of 6. Our time machine, sort of. The James Webb Space Telescope is a large infrared optimized space telescope. It'll probe for the first light after the Big Bang and find the first galaxies that formed in the early universe. That'll connect the Big Bang to our own Milky Way galaxy. The Webb telescope will peer through dusty clouds to see stars forming planetary systems, connecting the Milky Way to our own solar system, and find and look for chemical signatures of extraterrestrial life. All right, next up we have the Joint Polar Satellite System number 2. JPSS number 2 will provide operational continuity of satellite-based observations and products for NOAA Polar Orbiting Environmental Satellites and Suomi NPP satellite and ground systems like spy satellites, environmental monitoring, storm watching, cartography for maps, etc. We have the Mars Sample Return, or MSR. The Mars Sample Return campaign will bring samples from Mars to Earth. Perseverance will collect samples and leave them on the surface for an ESA-provided fetch rover to collect them to deliver to a Mars ascent vehicle, which would then launch the samples into orbit. Then an NSA and ESA-provided Earth return orbiter will collect the samples and take them in a capsule for return to Earth in the 2030s. The next project is the Space Launch System, or SLS. The Space Launch System, or SLS program, will develop a heavy lift launch vehicle to expand human presence to celestial destinations beyond low Earth orbit. This vehicle will be capable of lifting the Orion Mpcv to asteroids, the moon, Lagrange points, and ultimately to Mars. The next project is Psyche. Psyche is a journey to a unique metal asteroid that orbits the sun between Mars and Jupiter. The asteroid Psyche appears to be the exposed nickel core of an early planet. Alright, and the last project is the Roman Space Telescope, formerly WFIRST. The Roman Space Telescope hopefully will answer vital questions in both exoplanet detection and dark energy research. What other projects would you like NASA to work on? We'd love to hear from you. Email me at mel@thesolarSystemAmbassador@gmail.com. Thank you. How do you you get a baby astronaut to go to sleep? You rock it. We have new technology that can now detect sounds in space. So for the background of the next few slides, you will be able to hear sounds from space. STEM careers at NASA. First career is science and research. NASA focuses on science, planetary science, heliophysics, and astrophysics. With science, they mainly focus on Earth science, which is to study Earth from space. Planetary science is the origin and history of the solar system, potential for life elsewhere, the hazards and resources present as humans explore space. Heliophysics is to understand the sun. Astrophysics is the origin, structure, evolution, and destiny of the universe in search for life-like planets. Okay, they also do a little bit in biological and physical sciences, which is to learn how systems work at a fundamental level by studying them in space. The scientific objectives are to explore the vast unknowns of space and to use technology to improve life on space. And most scientists have a background of general physical science, astronomy in space, and physics.
So I'm Jim Green, I'm the NASA chief scientist. It just seemed natural that space is what I wanted to do. So then as an undergraduate, I got an astronomy degree, went on and got my master's and PhD all from the University of Iowa. It was easy for me to get involved because it was just all around me. You know, there are many ways to get jobs at NASA. For foreign students to be able to come and work in NASA after they get their degree, they can apply for a postdoc position. And NASA takes a number of international students and has them come to their centers, and they can work with scientists and potentially get really involved in the program. You know, NASA has been involved in a variety of what we'd call traditional disciplines, but it also is pioneering a couple other really important fields, like the field of astrobiology, bringing biologists and chemists and mathematicians and statisticians coming in and working together to figure out where one would go to look for life.
Data science, information technology, and cyber professionals. The goal is to find solutions to complex information technology, cyber, and data challenges. NASA's IT professionals design, maintain, and implement and protect IT systems. They provide easy access to information needed to fulfill our missions, ensure the security of that data, and the IT infrastructure. The next career is engineering. NASA hires 20 different types of engineers. The most common fields are aerospace, general, and computer engineers. They develop cutting-edge technologies and alternate propulsion and supersonic flight to transform the future of aviation.
I'm working on a SENS, which is an atmospheric remote sensing system that eventually will be put in space to monitor greenhouse gases such as CO2, to monitor global winds, which gives us a better ability to predict the weather and climate patterns. If you're trying to measure CO2 or ozone, the light wavelength or color that molecule or element responds to is different. So we design and develop laser systems to produce enough power in the right wavelengths that would allow us to actually make the measurement. And that's, of course, more challenging when you're trying to make that measurement from space because it requires more powerful systems where power is one of your limiting factors. You can't exactly stretch an extension cord all the way up to the space station. For me, the path was a very diverse one. I always enjoyed math and science. Wasn't really sure what I wanted to do though. I started out actually attending college, studying mechanical engineering technology. I was fortunate enough to get into a technician training program here at NASA. I worked as a technician for a number of years and really developed an interest and a skill and aptitude for working on laser systems.
All right, the next career is business services. NASA's business professionals oversee critical support operations and apply critical thinking, business acumen, and creativity to develop innovative solutions that move the agency forward. They advise and consult to ensure technical teams have the necessary resources and processes in place to successfully perform their mission. More than 12,000 people applied to be an astronaut between March 2nd and March 31st of 2020. To date, NASA has selected 350 astronaut candidates. The first U.S. astronauts were selected in 1959, and NASA has selected 21 more groups of astronauts as the original 7. The backgrounds of NASA's latest group of astronaut candidates include school teachers, doctors, scientists, and engineers. How do you apply to be an astronaut? Civilians apply through usajobs.gov. Active duty military also applies through usajobs.gov, and they need to notify their respective military service. Applicants with flight experience also need to apply through usajobs.gov, but they need to complete the GSC Form 601, which is the summary of aeronautical experience. Hey, this looks like Earth, but is actually Proxima b, the nearest Earth-like, potentially habitable world. The diversity of NASA. The vision of NASA is a diverse and inclusive workforce fueled by innovation and united in achieving mission success for NASA. NASA astronaut diversity. NASA astronauts are 90.7% Caucasian, 3.88% African American, 2.87% Hispanic, 2.84% Asian, 0.26% Native American, 0.26% Hawaiian, and 0% Middle Eastern. These are African American astronauts that entered space and an honorable mention.
These are the voyages of the Starship.
This is Julian Bluford. He was the first African American astronaut in space. Then we have Ronald McNair, who died in the Space Shuttle Challenger disaster. This is Ronald McNair.
Led you to become a candidate or become an astronaut?
Okay, well, given the desire and motivation to be involved in space exploration and an interest in that area, a couple of years ago, NASA began to canvass the country for space shuttle astronauts. And I saw one of these, saw that they were looking for scientists who did not necessarily have military backgrounds. And I fitted all the qualifications. I made my application along with 8,000 other people and went through the various screening processes and came out in decent shape.
We then have Frederick D. Gregory, who was the first African American to pilot and command a space shuttle mission, and he was acting administrator of NASA in 2005. We have Charles Bolton, the administrator of NASA from July 17, 2009 until January the 20th, 2017. Then we have Mae Jemison, who was the first African American woman in space.
Dr. Mae C. Jemison always believed in following her dreams. In fact, she followed her dreams right into space.
2, 1, booster ignition and liftoff of the space shuttle.
Born October 17, 1956 in Decatur, Alabama, but calling Chicago, Illinois her home, she always wanted to be a scientist. She believed it was her destiny to one day blast off into outer space. The young Mae also had a strong talent for dance, studying it from age 9. At age 16, she attended Stanford University on a scholarship, studying chemical engineering and African and Afro-American studies. While in her senior year of college, she was deciding between two careers, either a doctor or a professional dancer. She decided to continue on in the medical field. She applied to and was accepted by Cornell University Medical School. Dr. Jemison worked as a general practitioner in Los Angeles, California, before joining the Peace Corps in West Africa. She has also practiced medicine in a Cambodian refugee camp. In June 1987, Dr. Jemison was selected for NASA's astronaut program. Her love of dance followed her into space. She took a poster of the Alvin Ailey American Dance Company along with her on the flight. With a successful launch of the Space Shuttle Endeavour on September 12, 1992, Dr. Mae C. Jemison became the first black female to travel into orbit. The first thing she saw from space was her hometown of Chicago. Her young dream had come true, and she even danced in space. In March 1993, Dr. Jemison left NASA. She then founded the Jemison Group, which focuses on improving healthcare in Africa. Dr. Jemison has also had a television career. She's the only real astronaut to ever appear on a Star Trek series. She was the host and technical consultant for the series Worlds of Wonder. Dr. Jemison didn't let a lack of role models discourage her. She had big dreams and made them happen. She has been a doctor, a dancer, an astronaut, and a chemical engineer. But most of all, she has been an inspiration.
Then we have Bernard A. Harris Jr., who was the first African American to walk in space. Then we have Winston E. Scott, who's a veteran of 3 spacewalks, Robert Kerr Beam, who's a veteran of 7 spacewalks, Michael P. Anderson, he died in the Space Shuttle Columbia disaster. Then we have Stephanie Wilson, who was involved with 3 missions, Joan Higginbotham, who had 1 mission. Then we had Alvin Drew, who's a veteran of 2 spacewalks on February 28th and March 2nd of 2011, and he was involved with 2 missions. Then we have Leland D. Melvin. He was Associate Administrator for Education at NASA, and he had 2 missions. There's Robert Satcher. He did a spacewalk on November 19th and November 23rd of 2009. He had 1 mission. And we have Victor J. Glover. He joined the International Space Station Expedition 64 as the first African American on an international space station. He's also part of SpaceX Crew 1. Next we have Cian Proctor, whom I just recently met. She's the first African American female spacecraft pilot as part of Inspiration 4. She's the first African American commercial astronaut.
Pilot, and it's really special for me to hold that title because I'm going to be the first Black female pilot of a spacecraft. There have been 3 Black female astronauts that have made it to space, and knowing that I'm going to be the 4th means that I have this opportunity to not only accomplish my dream, but also inspire the next generation of women of color and girls of color, and really get them to think about reaching for the stars and what that means. So I feel very fortunate to have that. Space to Inspire has always been my motto as a teacher, and when I was talking to my students, you know, the thing about it was when I would say space to inspire, they're thinking outer space, but really it's this space, your space. We all have this unique space that we carry with us everywhere we go, and getting to know what it is that makes us passionate and how to share our unique gifts with the world is so important.
Then we have Michael Strahan. He's the first African American space tourist. And our honorable mention is Ed Dwight. He made it to the 2nd round of an Air Force program from which NASA selected astronauts, but was not selected by NASA to be an astronaut. He resigned from the Air Force in 1966 due to racial politics, and Kennedy picked him specially to go to the moon, but NASA rejected that. We would love for you to work for NASA or to serve your country as an astronaut. I'm reading a book about anti-gravity. It's impossible to put down. Astronaut training. Physical and psychological requirements for astronauts. People must be in top physical condition, be at least 4 feet 9 inches tall, good visual acuity, normal blood pressure, and most people are between the ages of 25 and 46. People who go to space are great at self-confidence, taking risks, stress management, multitasking, teamwork, public speaking, and testifying before. Education. College graduates. Many are scientists and have doctorates. Professional experience. Pilots and commanders have flying experience, military training, or space industry expertise. Science. Astronauts learn to fly aircraft, to work in mock-up trainers, first aid and medical care, save extra vehicle activity, and the science behind the experiments. Next up, we have physical training. They train in the Comet Vomit, an airliner that's used to experience weightlessness. They train in the neutral buoyancy tanks that allow them to simulate working in space environments. They practice land survival skills. They have some simulations in Cave, which is a virtual reality environment. They learn their new environments before they ever leave Earth. Then we have Astronaut Food. Astronauts have individualized nutrition plans. The diets have to meet the recommended daily allowances of vitamins and minerals. They use the caloric requirements determined by the National Research Council for Basal Energy Expenditure. They may eat from a standard menu, or they may substitute items to accommodate their own taste. But an astronaut design menu must be checked out by a dietitian. Preparation method. The preparation can be eaten in its natural form, like brownies and fruit. Some of dehydrated foods require adding water in space. A warming oven is available to maintain temperatures of food. There are no refrigerators in space, so space food must be stored and prepared properly to avoid spoilage. Astronaut food types. They have fruits and vegetables, salad, processed meats, processed fish, processed beef jerky, beverage packets, condiment packets, and salt and pepper are liquid in space. Disposable and in cans and tubes. Eating the food is a challenge due to having no gravity. There are specially trays, plates, and utensils that are magnetized so they do not fly away. Veggie is the vegetable production system on the International Space Station. It's the size of a piece of luggage, and each plant grows in a pillow filled with a plant-based growth media and fertilizer. Veggie has successfully grown 3 types of lettuce: Chinese cabbage, Mizuna, mustard, red Russian kale, zinnia flowers, and the future plants to be grown are tomatoes, peppers, berries, certain beans, and other antioxidant-rich foods. Then we have the Advanced Plant Habitat, or APH. It's a plant growth chamber. The water recovery and distribution, atmosphere content, and moisture levels, and temperature are all automated and in constant contact with the team at Kennedy. They have more LED colors than Veggie, and it uses a controlled fertilizer to deliver water, nutrients, and oxygen to the plant roots. The first harvest was in spring 2018. We have a current study that's studying microgravity and plant ligand content. The ligands in plants have functions similar to that of bones in humans. So we're studying this to determine the difference in microgravity.
All right, Mel, we lost you.
Event is coming up. Webb energizes you. This is for future engineers. Power to challenge. Webb energizes you, and NASA's partnered with future engineers hosting class students in kindergarten 12th grade. Here are how you can stay involved with NASA. We have different links for parents and caregivers, K-12 educators, higher education, and NASA internships. Here we have links to breaks and opportunities. Most of these are located throughout the U.S. History time. Astronomy in Egypt. Egyptians charted the movement of the sun and the constellation and cycles of the moon, and they had 12 parts to the year. Any comments? Email me.
Well, again, that was unbelievable. I mean, you're so talented. I mean, I knew you were taking it seriously, but that was absolutely phenomenal. Thank you so much for that. That was really good. Now, before I get to the students' questions, I was trying to explain exactly what a social or a solar system ambassador is, because I know you've recently got into this role with NASA. So what is it exactly that you do as a solar system ambassador?
Awesome, great question. Okay, so what we get to do is we get access to we get access to astronauts and other information like right before NASA puts it out for everyone else to see. So we get like a little bit more access. We find out about all these educational programs, and it's a really hard program to get into. Like a ton of people apply. They check your background. They do an extensive background check to select the people they want to be in this program. And that's about it.
So, and again, I mean, I know you have a,
but it's a pretty awesome program. I think.
I see. I mean, that was blowing my mind, the stuff you were just showing us. I know you have a background in biochemistry and environmental science, and you got the multiple degrees, but how did you get in, what led you to get involved in this?
Well, I'm really interested in outer space. So I was doing a lot of work with NASA and writing grants and such and all of this. And then I came across the program and I was like, this program looks amazing. And it's pretty much what we were already doing, but we just got more access to more, we just got a higher degree of access to NASA. So that's how we kind of got into it. That has to go because of a grant that I was helping like deal with. I found this program.
Yeah, and I know you did a brief thing about your background.
But it's pretty cool. It's really cool.
I see. I know you did a brief thing about your background on the presentation, but you did not include that you are a graduate of Madison County Schools. You're a graduate with me at Madison Central in 2000. So you are from the local area. I know you're in Louisiana now, but you are a product of Madison County Schools. So, you know, all the Madison County School students that see this now and see it later, you know, see that there's great opportunity. Now, why is the representation in the NASA field so important to you? Because you did hit on that and you talked a lot about it and highlighted a lot of very important Black space leaders.
Well, I think it's very important because we need all viewpoints. Sometimes we all see the world a little bit differently. And that's why we need more inclusion, because we need people who are able to say, hey, wait, this doesn't make sense. Or, hey, we need to be concerned about this. The more people and the more diverse their viewpoints are, the more, the greater our ability to achieve these goals will be. I hope that makes sense. So we just need more inclusion. We need more people. We need a higher rate of diversity. We need all of that. And you're right. I did graduate from Madison Central, class of 2000. Can you believe it? 22 years ago.
Yeah, that is crazy. But
that's crazy.
You showing those projects that NASA's working on, which was blowing my mind. Some of that stuff. You're right. The inclusion is important, not only of the racial makeup, but the educational background. You're going to need the engineers. You're going to need the scientists. You're going to need the pilots. You're going to need the. Yeah, I mean, you're going to need the people. So there's so many fields that are needed in the space field. It's not just an astronomy degree is important, but there's a lot of other moving parts that go into that. There's people that are in the space industry that never get off the ground, that do a lot of important stuff because, you know, what you said with all the exploration going on, all of that is not stuff that's in the air. A lot of those people are having the computer skills and having the engineering skills that are so important. But I do have a few questions to get to. And this first one is a tough one. So we'll start with the toughest one. This is Reginald Cooper, and he's in Kent. And he asked, how much do you think rocket and space technology will advance in the next few years at the current rate we're going in advancement already?
All right, repeat the question one more time.
Okay.
What is the rate? I heard that.
How do you think rocket and space technology will advance in the next few years at the current rate we're going in advancement already?
Oh, wow. Okay, so just in the last 10 years, we've come up with these reusable rockets. So I can't imagine where we're going to go from there. So if we already have reusable rockets, maybe we can come up with some reusable fuel or some sort of technology to keep the rockets where the rockets generate their own energy, perhaps. So that way they can get even further than what they're getting now. We're going now. That is an amazing question. And there's so many different ways to answer that. I'm just going to go with renewable energy. That's my answer.
Well, and you talked about this in the presentation.
Or self-generating energy.
And from what I've seen and read, the biggest problem in space exploration is finding a way to get things and people back. Because we know we can get to Mars. The problem is finding a way to bring it back. So, and I know you did have a slide on that's the current project for NASA because that is so difficult to figure out.
It really is. And then when you're in outer space, most astronauts started forming an iron deficiency. And then you have to worry about, they have a special dietitian to make sure that they get the correct caloric intakes. it's really hard to, we're working on how to sustain life in outer space to get those people home safe and sound.
Yeah, and that was a
Two
good
big things they're working on.
about that. You need nutritionists and doctors to make sure the astronauts are healthy while they're there and healthy getting back, because it is a lot trickier than the movies want to make you realize.
That's true. That's very true.
Yeah, this question is Brian
And that space anemia is real, so it's huge.
This question is Brian Mercer. He's in 11th grade, and he asks, what is the biggest pattern you have noticed in stars and planets?
The biggest pattern, well, I will say this, 95% of stars that are going to be born have already been born. So right now we're seeing there's still 5% of stars still left to be born. It's still quite a huge number. But as time goes on, you're going to start noticing the brightness of the stars at night are going to have started already getting dimmer. Our moon is moving away from us, so our moon is not going to be quite as bright as it used to be. So you're going to see basically our universe is stretching. So you're going to start seeing, it's just going to be a lot darker at night.
Interesting.
That's without the light pollution though. So just naturally darker. So that's a pattern.
Now, this is a Maya Dixon. She's in 9th grade, and she asked, what is the coolest thing you've ever seen?
Oh my goodness, the Skull Nebula is pretty cool. Black holes are pretty cool. Oh my goodness, those Earth-like planets, when Kepler went up there and started taking pictures, they found so many exoplanets that looked like they could possibly be, hold on one second. It looked like they could possibly enable human life. So that was really exciting as well. Very exciting.
Yeah, that Skull Nebula, that was a cool picture.
So I don't know. Space itself is just amazing. Just amazing. It was amazing.
This is Alonzo Johnson. He's in 9th grade.
Amazing.
And he asked, what do you think is the next big thing for your department at NASA?
Okay. Well, they're doing a lot with they're doing a lot with dark energy, and I think that's going to be a big thing right now with the James Webb Space Telescope. They're going, it's basically looking back in time. So we're trying to figure out if we can figure out like the way the universe has changed over time, we can kind of project as to where the universe is going. Like the universe is like 13.3 billion years old. But here's the thing though. As everything stretches apart, we're trying to figure out where we're going to end up at, or what's the future fate of the universe, because that's the better way to put it. So I think that's where people are going to start looking into more, like what's going to happen to the universe in the future.
Yeah, and that's a fair question. Now this is Blackman, and he's in 9th grade, and he asked, what made you want to get into this?
Because space is amazing, and like they said in Star Trek, space is the final frontier. Like I want to see if we can like possibly inhabit another planet, because we might actually need to one day. So yeah, that's what made me get into this. There you go.
All right, well, Mel, we're almost out of time. I just got a couple more for you, and I gotta have one funny one.
Okay.
These kids love making fun of me with a good cause, and you've known me for about 25 years now, and it seems like so
right.
And me and you are probably the two goofiest people I've ever met. So
I love it.
Somebody who's known me since I was 16 years old, can you honestly say that I have not been just the same goofy now as I was then?
Yeah, you're just as goofy. Just as goofy. Like when I was working in this presentation, I was like, this is gonna kill Greg. Yes, you're just as goofy as you were then, just as goofy.
Yeah.
Yes.
And so are you.
Yes, yes, people. He's just the same exact way. So funny.
I mean, it's just, and you still get my humor. I mean, you haven't changed a bit since we were in 10th grade. So that's awesome. But oh, and you were also my neighbor in high school as well. So that's kind of cool as well. So before we go, and I thank you so much. That was an incredible. And I know you're being mom right now while you're doing this. So that's impressive in itself. But, you know, you grew up in Madison County. You were a young Black girl with the big dreams that you saw of these same astronauts you just talked about. And even, you know, and you're not going to go into space, but you're still really involved in the scientific aspect of it. And you gotten a PhD. You are a you know, multiple degrees, and the level of intelligence you have compared to most people is just mind boggling, because it really is on another level. So, but yet you face the obstacles that these young Black kids are going to face. So what did you do, and what can they do to be just as successful as someone like you?
Well, they just don't give up. Know your dreams. Write down a whole list, a whole outline of what you want to be when you grow up, and follow it. Stick to it. Also know that a lot of these people that major in engineering, they started early. Like some of those programs I put up there, they started really early in these programs, these engineering, these programming programs, all this. So when they start college, they're already kind of ahead of the game because they've been working on it for years. So I'd say just find something you like to do, that you want to do, that you would do for free, and that's what you should do. And don't worry about how any of the stuff is going to fall into place, about your salary, any of that, because as you get older, like, the money usually comes, usually. But yeah, just follow your dreams, stick with it.
That's awesome. Mel, thank you so much. Again, that is one of the best presentations we've ever had. And I thank you so much for taking the time to do that on your crazy schedule. And I'm so proud to call you a friend and a classmate. It's just amazing what you've done over these years. And I got to see it.
So sweet. Oh, well, thank you for inviting me.
All right. Well, I know you got to get back.
Thank you so much. This was fun.
I'm glad you enjoyed it. I know you got to get back to being mom. I'll talk to you.
All right, cool. All right, awesome. All right, cool. All right. Thank you. Bye.